In today's video, we'll be performing extensive tests on the highly popular Jackery Explorer 500 portable power station and SolarSaga 100W folding solar panel. Let's go inside and get started with the Explorer 500 first. A while back on my channel, I showed you the Jackery Explorer Model 240, and that unit looks exactly like the one you see here. The only difference is this one is a larger unit, of course. This one has not two, but three USB Type-A ports. This one has a 500-watt AC sine wave output. You have the accessory socket, also rated 10 amps. You have these extra DC outputs. This is not on the Jackery 240, and this has an additional 7 amp output capacity. Now the Explorer 500 also has this 1 watt LED spotlight. The Explorer 240 does not have that. But what I did in another video is I showed viewers how they can modify their Jackery Explorer Model 240 to add a very nice Cobb LED area light. If you haven't seen that video, be sure to watch it after watching this video. Go back over here. On this end you have a cooling fan, and on the opposite end is where air is drawn in. The air flows through. It keeps the inverter board cool and all the other electronics, as well as the lithium-ion battery pack. Now right over here you can see the specifications for this unit. The battery pack is 24 amp hours, 21.6 volts, 518.4 watt hours. The unit weighs 6.04 kilograms or 13.32 pounds. The manufacturer states that the battery pack inside this unit can be cycled 500 times or more. The operating temperature for this unit is between -10 and 40 degrees Celsius. The unit can be recharged between 0 and 40 degrees Celsius. Now a look at the bottom of this unit, and you can see it has those rubber or maybe neoprene feet. On the Explorer 240 there is adhesive behind these, and when you peel them off the screw is there. This one has the screw through it, which is recessed. Now to turn on the display, I can push the button right here. And you can see state of charge for the unit, 72%. We have 4 out of 5 bars. Over here it says 0 watts. The wattage that's drawn would show up right over here. If you turn on the AC, you heard the fan come on initially and it goes back off. And you can see with this turned on and that turned on, the circuitry inside these is drawing just a little bit of power. It shows 3 watts. Let's turn this off, turn that off. And as you just saw, with all of these turned off, the screen went off by itself. Now, one thing to show you over here, when the battery charge drops to 20%, the entire screen is going to flash 10 times. When it drops down to 10%, it's going to do the same thing again, just to let you know it's getting very close to recharging the battery pack. Now, in order to preserve the battery pack's lifespan, the manufacturer recommends that once every 3 months, you use and recharge the Explorer 500. Something like this is ideal for a weekend getaway if you're going to go camping or in the event of a power outage. Right over here from the box you can see the charging times, and it shows 3 different methods. One is using the AC adapter. This is a 25.2 volt regulated output, 3.5 amps. Plug this into the AC receptacle and this plugs right into here. Using that method is going to be the fastest way to recharge the unit. Another method is using the accessory socket in your vehicle. Take this, plug it into your accessory socket, this end here into the port, and keep in mind it's 12 volts coming out of your battery, or 12.6. And because you're using a lower voltage, the wattage is going to be lower, and I'm going to show you that in a minute. When I take this outside, plug it into my accessory socket in my vehicle, you'll look at the wattage with the engine off and the wattage with the engine on. And the last way to recharge this is using the 100-watt SolarSaga panel. Now before I get started performing extensive tests on the Jackery Explorer 500 unit and the solar panel, I just want my viewers to know that this was supplied to me for free by the company. Just because it was supplied to me for free does not mean that you're going to be getting a biased review. If I see something I don't like, you're going to know about it, and if I see something I like, you're going to know about that as well. Now let's take a look at the light first. You push the button once, and it may not appear too bright on camera, but it is fairly bright. I'll give you a lux reading in a minute, but you could use the light, or you could push the button, and now it's on SOS. And just push the button again to turn it off. So let me push this to the side. I have my light intensity meter set for maximum. Put this on, and let's hold it right in front. And the reading we have is 52,200 lux. And you can see if I compare the light to a flashlight, this one here is a warm white, and this one over here is a cool white. You can see it has that whitish blue, and this has more of that yellowish look. Alright, now I want to take a look at the USB outputs. According to the manufacturer, these can handle up to 2.4. Let's turn this on, and I'm going to be plugging into one of the ports. Now before I give you a better camera angle looking down at this display, I wanted to let you know that this entire bank with the 3 USB Type A ports has a maximum output of 30 watts. So let me start with 2.4 amps first, see how well it works. We'll take a look at the output voltage, and then we're going to slowly increase all the way up to 4.1 to see how well this port can tolerate the higher load. You see 2.4 amps, and it's not activated yet, so let me push this button. No wattage. 5 volts coming off the Jackery. Now let's activate right there. We're showing 12 watts and 5 volts. And what does this look like right here? And that's showing 11 watts. Alright, let this sit a minute, and then I'm going to increase the current. Okay, let's take a look at the display. Still 11 watts. Now I'm going to go over here. Let's turn this higher up. Let's go to 3.1. I have a feeling that all the ports are in parallel, so it's probably going to let it do it. Let's see. That's close enough. Now let's push this button right here. 15.4. 15. And still 5 volts. Pretty good. Let that sit a minute, and then we're going to take it up to 4.1. It's been running fine for about 15 minutes. The cooling fan is going. Let me put this back on the display. 15 watts. Now let's increase again. Let's push this right here. Oh, I turned it off. Put it back on. And let's increase this. Let's go to 4.1, I think it goes. Put some serious current through here. 409 is it. Alright, and what do we have here? 20.4, that's watts. 5 volts still. And you can see 19 watts. Now what I'd like to do is leave this connected for the 20.5 watts. And then I'm going to take my cell phone and plug it in. I want to get as close as possible to the 30 watts to make sure this can handle it. So let me turn this back on. That's 4.1, and this is going to go to 20. Now let's add my phone, and let's see what we get. Perfect, 27 watts. I'm going to let this run about 15 minutes just to make sure that this does not turn off. 15 minutes has passed, and this did not turn off at any time. Still 27 watts. So 30 watts should not be a problem. The next thing I want to do is turn this on and place a 10 amp load on the accessory socket. The electronic load is connected to the accessory socket. It's turned on. Let me put on the backlight. And I'm going to keep it around 120 watts or maybe just a little less. And that's the rating for the receptacle. I'm going to do that for about 10 minutes. Here we go. Alright, for 121. That's good. Leave it right around there, and hopefully this holds up just fine. That was at least 15 minutes. and there was no problem at all. Accessory socket worked the entire time. Alright, let's take a look at one of these now. We're all connected up in this jumbled mess of wires. This is 16 gauge wire, and we're plugged in right here. Let's turn that on, you can see it, and let's set it for 7 amps. That was 15 minutes, and it was no problem at all for this port. So we know this can handle the power, we know this accessory socket can supply 10 amps of current, and we know these DC outputs can supply 7 amps. Now what I'm going to do is show you that this AC receptacle has a sine wave output. Looking at the sine wave waveform off of my AC line in my house, peak to peak is 344 volts. So from the zero line, which is the middle, it goes positive 170, and from the middle line, which is 0, to negative is 170. So from top to bottom gives you the 340. Of course, when we measure voltage, it's an average, so it comes out to right around 120 volts. Now I'm going to connect up the portable power supply, and we're going to take a look at the waveform to compare. Okay, we're all connected up on the portable power unit. Let's take a closer look at the screen. And as you can see, it's identical to the one for my AC mains. 344, you can see it's touching that bottom line, touching the top line. So it does have a sine wave output. Now I'm going to be doing 3 different tests. I'm first going to plug in an inductive load, a power tool. I know it draws every bit of 500 watts. And of course, when you start it up, it's going to be drawing more than 500. This unit has a 1000 watt surge capacity. So let me plug in this angle grinder. I'm going to place this off to the side, and you could look right over here. No problem at all powering the angle grinder. And it was hard to hear because the angle grinder was running, but when the load gets high enough, the fan comes on. Now we're going to test for overload, so let me unplug this. And to do that, I'm going to be using a heat gun. And let's plug it in right over here. And now I can turn it on. You'll see the wattage right here in the bottom. There is a delay to this. Just turned off. And you can see there's a caution sign. It's got an exclamation point. That's letting you know that it's been overloaded. So all you have to do, turn it back on, and now it's ready to try again. So as you saw, by overloading it, you're not going to damage the unit. Now if you're wondering, the Jackery can supply over 500 watts for a short period of time. I'm going to show you using this travel iron. Let's plug this in and turn it on. Keep an eye right over here. And you can see we're around 550, 560. And you can probably let this run about 15 minutes before this would get too hot and disconnect the load. Now for the last test for the AC receptacle, what I'm going to do is I'm going to take a 500 watt load, or just a little under, and I'm going to hook it up to this receptacle and see how long this unit can run. The temperature inside the house is right around 76 degrees. Hopefully it can run without overheating. If it does overheat, I'll let you know. And at the end, we'll know exactly how many minutes it ran using that load. Let's give it a try. So the first thing I need to do is charge up this unit to 100%. Let's take the power supply and plug it in. And let's see what we have. Here we go, 80 watts. I'm going to let this charge for a while, and then before it's completed, I'm going to take this into my vehicle and I'm going to plug it into the accessory socket to see what kind of wattage we get with the engine off at 12.6 volts. Then I'm going to start the engine with the alternator running. It should be around 14.2 volts, and we'll take a look at the wattage reading again. We'll have an idea of how this charges using different voltages. And let's see what kind of wattage we get with the engine off. And right there, 36 watts. Alright, so that's kind of low. Battery voltage is around 12.6. Let me start the engine, and the wattage should go higher when the engine is running because the voltage will be around 14.2 volts. And now we're up to 43 watts. So even if the 100 watt solar panel tests good, there's a chance that you're not going to be able to fully utilize the output of that panel. So let me connect this up first. And right here is 12.6 volts. Hopefully you can see 2.84 amps and 39 watts. So it's very close to what the car was with the engine off. Now let's put this to 14.2. Let's see if that's around 43. And we have 44 watts, just like when my engine was running. Now I want to go to 18, just like the solar panel. And let's see what it's going to be. Wow, so 18 is 57 watts. And let's try 20. Well, we go over here. There, 20 volts, 20.2. And that's 64 watts. So based on what I see right here, if the solar panel is connected to this unit, we're only going to get 64 watts. And that's a little disappointing because if you're going to be getting a 100 watt solar panel, you at least want to see 100 watts show up. So we'll find out later when I test the panel if it's going to be 64 watts or it's going to show up as 100. Now according to the manufacturer, we could go as high as 30. So let's put this to 30. Right there, 30.2. And now we're at 96 watts. They claim this has a 100 watt input maximum. I wish this would stay on, but it doesn't. So let's slowly increase this. 30.5. Now we're at 98. Let's go to 30.7. So we're staying right around 98. 30.9. So we're maxing out at 30.9. According to the manufacturer, this has a over voltage input protection circuit. So if you put too much voltage right here, it's going to stop charging. So let's increase and see if it does that. Now we're at 31. Oh, look at that. It just turned it off. So it does have over voltage protection. Let's go back and see if it goes back on. A little bit more to 30. Right there. Let's see if it comes back on. Yep. So I have to say it does have over voltage protection, which is good. Let me finish charging this so we could do the test with the AC receptacle. You can see we're now at 100%. While the Jackery 500 was charging, there was no issue at all with excessive heat. Before I connect the load, I want to take a look at the accuracy of the meter right here when used with this receptacle. So let me plug this in first. I'm going to take this 100 watt light bulb, place it back here. Let's plug it in and compare here to there. And it's a little slower, but you can see this is 84.7 and this is showing 88. This is showing just a little bit higher. Let's turn this off. All connected up now. I have all the loads ready to go. Over here is a 40 watt incandescent lamp. I have the mini heat gun in the back. Over here is a 100 watt incandescent lamp. And right over here, 150 watt soldering iron. Now what I'm going to do is, once this starts up, is push everything away from the Jackery. I don't want to have a lot of heat around this unit as the fan is running because I don't want to have this false trigger. The temperature in my room is 76 degrees. I'm going to turn it on and we're going to see how long this unit can sustain almost a 500 watt load. And that is it. We averaged around 488 watts for 59 minutes. The unit never turned off and it never overheated. So the Jackery 500 did extremely well using that load. The manufacturer says the battery pack has a 518 watt-hour capacity, and we came in a little bit under, but still pretty good. Now I'm going to let this cool for about a half an hour, then I'm going to charge it up, maybe 3/4 of the way or a little bit more, and then we're going to take this outside and do the testing with the solar panel. Just to show you, if you drain this all the way down to 0% using a heavy load, and you do not let it cool for about a half an hour, when you go to charge it, you can see it started to charge, but there's a little thermometer right there, and it's letting you know that the unit is still too hot to be able to charge it. So once this cools down, this little symbol will disappear, and then you'll see the 80 watts coming from this switching power supply. Okay, you're looking at the SolarSaga panel folded up. Now I want to go over the construction first, and then we'll open it, we'll take a closer look at the solar panel, and then we're also going to be testing the outputs. It's important to note that the panel is not waterproof. It's rain resistant. So the material you see here, it's a cloth material and it has a plastic backing on it. So if this gets wet, it's not going to absorb the water. Right over here, you have a kickstand. So when the panel's folded open, you'll be able to hold the panel at the correct angle. And you could position it any degree, like from there to there, and then when you're done, you just push the strap back in and just push it against the Velcro. Both sides have this. The panel's very comfortable to hold due to this rounded off handle. The material is TPE, thermoplastic elastomer. For certain situations, you may want to secure the solar panel, and you can do that because the panel has these corrosion resistant grommets on both sides. Let me flip it around, show you the opposite side, and then I want to take a closer look at the handle. On this side, you can see the handle's flatter. That's because on this side, that's where the electrical connections are. SolarSaga 100 watt, 18 volt. You can see the grommets each side, and you also have that tilt out support with the Velcro. Let me show you what's inside this pocket. And you can see that waterproof fabric backing, plastic. Right here's a closer look at the cable. You can see the Anderson connector. This is going to plug into the opposite side, which I'm going to show you in a minute. And this connector here goes into the Jackery unit. You have around 6 to 8 feet of cable here, or 2 to 2.5 meters. Right here is a power indicating LED. When this is placed in the sun, you're going to see this light up, indicating that the panel is transferring power into the electronics over here. You have a USB Type A and USB Type C. The USB Type A is rated 2.4 amps, and the USB Type C is rated 3 amps. One of the tests that we're going to be doing is make sure that both of these outputs match with the manufacturer states. In case you're wondering, the weight of this panel is right around 10 pounds, or 4.4 kilograms. When folded, like you see here, the dimensions are 1.8 inch thick, 24.5 inches long, 22 inches wide. Now let's take a look at the opposite end. To connect the Jackery unit up to the panel, you're going to take this Anderson connector, slide this button towards the end, open the door, grab the connector, move it outside, and then you're going to make sure that this is all the way to the end so the door remains closed. Once you do that, very easy, you're going to line up the ends, and they click together. Okay, let's open up the panel so I can show you exactly how it looks when it's unfolded and go over some more features. Now, one thing I really like about this panel is how the two come together. It's magnetically attracted. See that? Inside here, there's a magnet, lines up with steel in these openings. And you don't have to worry about these ends separating, because when you hold your hand inside the opening, it keeps both together nice and tight. This is what it looks like when it's unfolded. Let me give you the unfolded dimensions. 0.9 inch thick, 49 inches long, 22 inches from top to bottom. This panel has 32 monocrystalline cells connected in series. Many of these portable folding solar panels use a material to cover all these solar cells called PET. PET stands for polyethylene terephthalate. That material allows 90 to 93% of the light to pass through it to get to the surface of the solar cells. The surface is resistant to rain, but it's not resistant to acids or alkalis. Now, knowing that this can possibly get wet if it's left outdoors when you're charging, the only thing that I see that I don't like, everything else I like about it, the material, the surface of the panel, right here, these screws, there's 16 of them all together, and they're about that long, about 3/8 of an inch or 10 millimeters, and they did not use stainless steel. And the added expense is not that much, so I'm surprised they didn't use them, because over time, if you do leave this outside and it gets wet and you wipe it with a towel, eventually you're going to have rust form on the surface of these screw heads. So one change I'd like to see them make is in the future to make these stainless steel screws. Okay guys, the panel's been sitting in the sun for about 20 minutes and you're looking at the open circuit voltage with a reading of 81,800 lux. Now let's take a look at short circuit current. And you can see it's slowly climbing up. Light intensity is 81.9. All right. 82.2, yep. 6.97 short circuit current. Okay, let's take a look at the power output for this panel using my electronic load. Now, according to the manufacturer's specifications, this panel can supply 5.55 amps at 18 volts. Let's test that right now using this electronic load. Right now we're at 81,000 lux. And 1778, right around 5.3. If our sunlight intensity was just a little bit higher, around 85,000 lux, then this would definitely be able to supply 555 at 18. Okay, we're hooked up to USB-A. The voltage off the panel, 5.1, no load. All right, let's activate. 2.4 amps, 10.8 watts, 4.5 volts. So that output's working well. Now let's test USB-C. We're hooked up to USB-C and now I have it set at 3.1 amps. The voltage to start open circuit is 5.1. Let's activate. 14.2 watts, 4.6 volts. USB-C also works well. We now have the Jackery Explorer 500 connected to the solar panel with a light intensity of 81,800 lux, and just as expected, only 64 watts is being utilized from the 100 watt solar panel. And that's very disappointing. In my opinion, it pays to buy the SolarSaga 60 watt panel to use with the Explorer 500. It's much cheaper and you'll get around the same input power, maybe slightly less, but if you're looking for a nice 12 volt 100 watt monocrystalline folding solar panel with USB Type A and Type C ports, then the SolarSaga 100 may be for you. Based on my testing results, the manufacturer did not exaggerate the specifications for this panel. I do want to show you one thing. Right over here, there's really no reason to have this string right here, or this band. I suggest cutting it clean there and cutting it clean over here, because this is limiting the angle that you can place the solar panel on. So if you remove it, you can get this to go further back, and the panel can go at a different angle, much lower. So just cut that off right here, nice and clean, and then you can just stick it back. And guys, that's it. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thank you very much for watching.